Well, the workshop is about signal processing. It is suitable for basically any data scientist that is dealing with diverse data, because not only the amount of data is ever increasing, but also the diversity. So you can think about speech data for speech recognition purposes, or time series in general, voltage signals from households, image data, and we will see how you can do speech recognition, for example, how Siri works, or how you can do image recognition or image manipulation with deep convolutional neural networks. Well, we define a signal as a function. That's the general definition. A signal is a function that takes a certain value at a certain time or a certain location in the case of images. And that means that any mathematical operator can be applied to that function in any of the domains. Well, nowadays, of course, you have deep learning and convolutional neural networks with which a lot of problems have been solved, and the general performance has increased quite a lot. But still, it's important to understand exactly what is happening inside those models and in the convolutional layers, so that you can apply it exactly in the right way in your setting. And also, if you don't have a lot of data, then deep learning usually doesn't work so well. So it's important to understand signal processing techniques if you don't have so much data, so that you can engineer the features yourself. The workshop starts with an overview of possible applications in the domains of time series, speech recognition, image recognition. And then we will cover some fundamental concepts of signal processing. Most notably, we will cover the convolution, so you will understand exactly what a convolution is and how you can use it. Also, we will use Fourier analysis so that we can decompose a signal into its frequencies, so its harmonics, different sines and cosine components of the signal. Then we will apply those techniques to classify time series data. In this case, I have some time series of disease outbreaks in the US. And we will also apply the techniques to extract features from speech data, so that we can identify a speaker or its age or his or her gender. And finally, we will also apply the signal processing techniques and deep convolutional neural networks to image data for visual recognition. I will cover quite some theory of signal processing in the first part, and in the second part I will show a lot of practical examples in Python, how you can apply those methods and hand it out afterwards so that you can use it yourself.